All right, now we're going to look at intercepts and how to graph using the intercepts and also how to graph using slope-intercept form. So when we talk about intercepts, we're talking about the point at which the graph crosses the x-axis or the y-axis. The point at which the graph crosses the x-axis is called the x-intercept. So as you can see on this graph, there's the x-axis and there's the x-intercept. Intercepts are always written with a value for whatever your axis is. For example, your x-intercept crosses the x-axis here at the point 2, but doesn't go up or down off that line. So the y value for that is 0. So you're always going to have an x value, and your y value is 0. So it's going to be x, comma, 0 for your y value. Likewise, on your y-intercept, it crosses the y-axis, so you don't go left or right, so your value for x would be 0, and your value for y would be whatever the value where it crosses the axis. So in this case, it would be 0, -8. So let's identify and label these intercepts. If you look here, the x-axis, the line crosses it at -1. So your x-intercept would be -1, comma, 0. There's a value for x and 0 for y because it doesn't go up or down. Your y-intercept has a value for y because you go 0 on your y-axis and you go up 1. You go 0 on your x, left or right, but you go up 1, so you have a y value. So, to solve, we can use intercepts to help graph lines. To find the x-intercept, we're going to substitute in 0 for y and solve for x. To find the y-intercept, we're going to substitute 0 for x and solve for y. So if you're finding the x-intercept, you're solving for x. If you're finding the y-intercept, you're solving for y. We're going to graph the linear equations by finding and plotting its intercepts or using slope-intercept form. How you're going to tell how to graph is first you're going to note that when an equation is written in slope-intercept form, y equals mx plus b, you're going to use the slope m and the y-intercept b to graph. Also note, when the equation is in standard form, which is x plus y as a number, we're going to make a chart and place a 0 value for x to find y, then put a 0 value for y and find x. If you don't get a whole number value for the missing variable, we're going to put the equation to y equals mx plus b form and go back to the original thought about starting with the y-intercept and using your slope to graph that line. So what we're going to do first is, if we look at this graph, this is in y equals mx plus b form, where my b is 2, which is your starting point, on my y-axis. Since it's your y-intercept, it's going to cross the y-axis at 2, and that's where we're going to start. From there, we're going to use the slope and the slope, we notice, is the number attached to x. So we're going to go down 1 over 3, since it's negative. So from this starting point, we're going to go down 1 over 3. And then draw your line. Make sure that we see the line there, the point there, and then draw your line as straight as you can. I'm terrible at drawing straight lines, so we're just going to try our best. Terrible at drawing straight lines. Awesome. All right, so that's one way. If your equation is in y equals mx plus b form, you're going to start at your y-intercept and use the slope to find your next point. Once you have 2 points, go ahead and make that line. If you want to make it clearer, you can by, let's move let's move. Oh, can't move it. All right. You can make it clear by starting there and go down 1 over 3 again. So my next point should be here. As you see, my line's a little bit off. All right. On my next equation, it's not in y equals mx plus b form. Now it's in x plus y as a number form. So we're going to substitute zeros in for x and zeros in for y. So when you do that, I have x minus 2y is 8. So when I say that x equals 0, then what is y? If x is 0, it does not exist. So I'm going to make it not exist. And I'm going to divide by -2 to find out what my y would be. Y would be -4. So my first point would be 0, -4, and I will plot that at 0, -4. And my next one, if I make y 0, x is what when y is 0? When y is 0, everything attached to y cancels out. And I have just x equals 8. I don't even have to do any math. That was perfect. So we have 8, comma 0. So my point is 8, 0. Oops, wrong way. Then I'll go over to 8 on my x-axis and put a dot. And then I have my 2 points where I can connect the line as best as I can. Make sure that I see that point and that point. What? That was awesome! I know. Okay, let's move on. So graph the linear equation by making a table of values using x and y intercept or using slope-intercept form. Go ahead and graph these and then turn it back on to see if you graph them the same way I graph them. First, I'm going to make x and y 0 since it's in that form, and I say 2x plus y equals 5. 2x plus y equals 5. If I make x 0, what is my value for y? If that's 0, it doesn't exist, and y is 5. If I make y 0, then y doesn't exist. I'll divide by 2. Oh no, and I get x is 2.5. Oh no. Since y is equal to a decimal, or x is equal to a decimal, I don't want to plot 2.5 right there because I'm not quite sure that that is 2.5 exactly. It doesn't fall in the dot lines. I want to actually change my equation then so I have a more exact line. So when you get this, I'm going to move some things down here. Let's move. Thank you. Bear with me. Okay. Oh no. Change the form. Change into y equals mx plus b form. So I have 2x plus y equals 5. I'm going to keep y here and bring my 2x over. So y equals -2x plus 5. Y is by itself, that's better. So start at B on my y-intercept, y-axis. So I'm going to start at 5. And then I'm going to use my slope to find the next point. My slope is -2, so I'm going to go down 2 over 1 from my y-intercept. So here I'm going to go down 2 over 1 from my y-intercept. I'm not going to start back at 0. I'm going to start where it crosses my y-axis. And then I'm going to draw my line. I'm the worst. I'm going to go down 2 over 1. I'm going to just continue that because then my line's straighter. And actually, then I'm going to see that if I go back to my intercepts, if y was 0 and x is 2.5, look, it crosses there at 2.5. But it is more exact because I put the points on the line. My line is a little crooked. All right. So, next, I have 8x plus 3y is 12. When I make x 0, my y, x crosses off, my y is 4, because I divide by 3. When I make y 0, my x became 12 over 8. Oh no, that's not going to work. So to change the form so that I could graph. I'm going to pause this for a minute. Okay, I paused it so I could move all that other stuff over. So when I change the form, then I'm going to go, now 8x plus 3y is 12. So I'm going to move my 8x over by subtracting 8x. That way my 3y stays there. When I divide by 3, I get y equals negative 8 thirds x plus 4. Then I'm going to start at 4 on y-axis. Then from 4, I'm going to go down 8 and over 3. So start at 4 on y-axis. And from there, I'm going to use my slope to go down 8 and over 3. If I did 12 over 8 into a decimal, I would have 1.5, and look, it goes through at 1.5. What? That is awesome! Right? If I'm graphing x as negative 3 or y as 6, I notice that there's not an x or y. There's not an x and a y in those equations. So when I notice that there are not two variables, when I notice there are not two variables in an equation, I am going to plot where the number lies on that axis. For example, x is negative 3, so I go where x is negative 3 and plot. Then draw a line that goes through the axis at that number. So it's negative 3 here, so I'm going to draw a line that goes through negative 3. That represents that line. The reason why is that says x is negative 3, so anywhere on that line, x is always negative 3, but y always changes. But x is always negative 3. If you go over to the y-axis and you say, well, y is 6 right here, then I have to draw a line through the axis at 6 because x can change, but y is always going to equal 6, and it won't always equal 6 unless you draw that line that goes through. What? That is so sweet. Cool. Cool. We're going to stop there.